Welcome to our comprehensive overview of pumps for private water supply systems. Today, we are going to explore the scientific principles behind how these pumps work, the different types available, and the best practices for sizing, installing, and troubleshooting them to ensure a reliable water supply for any residents. Let us start with the workhorse of the industry, the centrifugal pump. This pump uses an electric motor to spin an impeller at high speeds inside a housing called a volute. As water enters the center, or eye, of the impeller, it is thrown outward by the spinning vanes. The volute case gradually widens, which slows the water down and converts its high-speed kinetic energy into usable pressure for the home's plumbing system. You might wonder how a pump actually lifts water. It does not pull the water. Instead, it creates a negative pressure, or vacuum, inside the pump case. Atmospheric pressure pushing down on the water in the well then forces the water up the pipe. Because atmospheric pressure is limited, the absolute maximum theoretical lift at sea level is about 34 feet. However, due to friction and pump inefficiencies, the practical limit is only about 25 feet. When a standard centrifugal pump is not suitable, we might use a reciprocating or piston pump. These are positive displacement pumps that use a piston moving back and forth inside a cylinder. A single-acting cylinder moves water on only one half of its stroke, while a double-acting cylinder has a clever arrangement of check valves that moves water on both the forward and backward strokes. These are excellent for low-yield wells or water with a lot of sandy grit. Next, we have jet pumps, which are essentially centrifugal pumps equipped with a special nozzle and venturi assembly. This assembly forces a stream of water through a narrow nozzle, creating a strong vacuum that draws in additional well water. For shallow wells, this jet assembly is bolted right to the front of the pump. For deep wells, the jet assembly is removed and placed deep down inside the well, connected by two pipes, a drive line and a suction line. For many modern homes, the submersible pump is the top choice. As the name implies, this pump is designed to be completely submerged in the well water. It features a sealed electric motor at the bottom and a stack of multiple impellers above it. Because it pushes water up from the bottom rather than trying to suck it up from the surface, it is highly efficient and can lift water from depths of hundreds of feet without losing prime. Selecting the right pump requires careful sizing. You must balance the yield of the well with the peak demand of the household. For a typical residence, we calculate a 7-minute peak demand period based on the number of bathrooms. For example, a home with 2 bathrooms generally requires a pump capable of delivering about 12 gallons per minute. If the well cannot produce that much, you will need to incorporate a larger storage tank into the system. When installing the system, protecting the water line from freezing is critical. This is achieved using a pitless adapter. This clever fitting attaches to a hole cut into the side of the well casing below the frost line. It allows the internal drop pipe to connect securely to the underground service line running to the house, providing a sanitary, watertight seal while still allowing the pump to be easily pulled up for servicing. Inside the well, the drop pipe supporting a submersible pump is usually made of heavy-duty polyethylene. Connections must be incredibly secure, typically using double stainless steel clamps positioned in alternating directions over barbed fittings. Additionally, a rubber device called a torque arrestor is clamped to the pipe just above the pump. This prevents the pipe from twisting and chaking against the steel well casing every time the powerful motor kicks on. Even the best systems occasionally need maintenance. If a pump stops working, a technician's best friend is a multimeter. By clamping an ammeter around the power wire, you can read the electrical current draw. An unusually high amperage means the motor is working too hard, perhaps locked up by sand. A very low amperage means the motor is spinning freely without doing any work, which usually indicates a dry well or a lost prime. To wrap up, a reliable private water supply depends on matching the right pump technology to the specific well conditions. Always size the system for the home's peak demand. Use high-quality components like pitless adapters and torque arrestors during installation, and never compromise on electrical safety. With these principles in mind, you can design and maintain a water system that provides years of trouble-free service.